All right, welcome to hyperbolas. We're going to start by looking, the equation is going to look a lot like the equation for ellipses, but they're going to be a little different. So the first thing I'm going to show you is that here we have x squared minus y squared equals 1. So that's the first difference. There's going to be a minus there. Similar to an ellipse, they're going to have numbers here. Many times, to make it easier, they're going to be perfect squares. The way you graph this scenario is in the x-axis, you take the square root of this number, which is 3. So I'm going to move over 3 units from the origin. This shape is centered at the origin. And I'm going to take the square root of this y number, which is 4, and I'm going to move up and down 4 units. From there, we make a box with those dimensions. Alrighty, now through the corner of each box, we're going to draw a line. These lines will go through the center of your shape, meaning since it's centered at the origin. And then now, this might be the weirdest part of this whole situation. The hyperbola is created by using these endpoints. That's the point 3, 0 and negative 3, 0, and drawing these curved shapes that get close to these lines like such. Again, they're asymptotes, they never touch. Same thing over here. And the reason why I knew that this is what's called a horizontal hyperbola, it works its way to the left and right, is because of this negative here. The negative means that it moves away from the y-axis. So we're going to try another one very similar to that. X squared over 25 minus y squared over 36 equals 1. This again, since it has nothing in here like x minus 2 or y plus 5, it's centered at the origin. I work my way on the x-axis, left 5 and right 5, up 6, down 6. Let's go. Now I make a box through those points. I'm going to just mention one thing here. To get from the origin to this corner, I had to go over 5 and up 6. The slope of this line here is 6/5. In fact, the equation in this line is y equals 6/5 x. To get from the origin to that endpoint, I had to go down 6 and over 5. This has a negative 6/5 situation. Let me go sky blue. Again, I'll remind you, since the negative is on the y, it moves away from the y-axis. It starts at these endpoints here, 5, 0, and 0, negative 5, and gets closer to these asymptotes. That's what the shape looks like. Again, if you fire this into Desmos, it can confirm that. So now we're going to do one that moves vertically. They just often rewrite it like this. Y squared equals, over 49 minus x squared over, let's say 16 equals 1. This time, again, it's centered at the origin. I move my way over 4 because that's the square root of 16, and up 7, down 7. And I make my box, and I draw my asymptotes. So everything is drawn the same thus far. And now it's just recognizing that since there's a negative on the x-axis, here's your x-axis, we're moving away from the x-axis. That means we're starting here and drawing the shape vertically. It's going to get a little squeezed in here. If they ever, let me undo the ink here. If they ever gave us something like this, x minus 3 squared over 9 minus y plus 1 squared over 4 equals 1. You start by identifying the center of your object, which this shape is centrally located at the point 3 comma negative 1. So I'll notice this 3 comma negative 1. That's kind of where we're starting from, so to speak. Now when I do the square root of 9, that helps me from here move over 3. That's here. And from here moving over 3, which gets me to there. And again, I take the square root of 4. That tells me I move from the center up 2 and down 2. And now I have my box. Now I have my asymptotes that are drawn as such. And this negative on the y-axis, or pardon me, the negative on the y value means that it's, again, moving away from the y direction. Let me do this in green. So it's going to be, it just implies that it's a sideways pointing hyperbola. So that shape would look like this. If there was a plus there, that shape would be our ellipse that's wedged in there. And that's the relationship. And if you use Desmos, you can see this.